Myself, Mridula Shukla, Assistant Professor from the Department of MCA, the Oxford College of Engineering. I will be talking about computer basics. So in this, I will be covering the topics like computer organization, CPU, input-output devices, computer memory, programming languages, types of softwares, internet and web, database, information system. So basically, computer system is used for computation purposes. Computer system is composed of central processing unit, which is further divided into control unit and ALU, memory and input-output device. Now, you can see how they are related to each other. This is input-output is connected to CPU, which CPU is further divided into control unit, ALU, arithmetic logic unit, and memory. Now, CPU is, as we have seen, that control unit. So control unit controls different components of the system, and ALU, that is arithmetic logic unit, is used to perform arithmetic operations and logical operations. So how it does it? So control unit is the part of CPU that fetches instruction from memory. Each instruction is decoded to determine what exactly it is supposed to do. Once decoded, each instruction is executed. This cycle continues until the system is powered down. So this can be understood by the diagram. Instruction is fetched and decoded and executed. The cycle continues. Now we can see, we'll see that this I have already told to you about this. So logical operation is used for comparing values, and it determines whether they are greater, lesser, or equal. And here you can see connection with ALU and registers. Data is there in registers, and operation is performed in ALU. So the data is transferred with the help of buses. Now storage. When we talk about storage, the data is stored in memory, and the data is retrieved for operation from memory, as well as after performing operation, it can be saved in memory. So there are two types of memory: primary storage and secondary storage. Primary storage is the memory that is immediately available to CPU and is normally fast. It is also known as RAM, or random access memory. Secondary storage is directly available to CPU and it's typically slower. Example, hard disk, tapes, etc. Now, input-output devices. So output device is critical since it is the one responsible for receiving and sending data to the outside world. There are many devices that can be used as input or output. Keyboards, mouse, graphic tablets are example of input devices, and screens, joystick, apart from that, printers are all output devices. So we'll see input is any data or instruction that is entered into the computer memory, and you can see output. Output is the result of inputting data into the computer. The computer processes whatever input you will give, it will process the data, and computer sends out the processed information by means of output devices. We have already seen output devices, screen, printer, voice or sound which comes out. Okay, so devices, these are the examples of input devices: keyboard, mouse, scanner, joystick, microphone, digital camera. And in case of output devices, computer screen, speaker, printer. So this, or you all are aware of it. And so we'll move on. Speakers are output sound from your computer. Device is used for outputting text. So in case of memory types, we are talking about RAM. So RAM is further divided into ASRAM and DRAM. ASRAM means static RAM and DRAM means dynamic RAM. So SRAM is generally used for cache memory, which is made up of flip-flop gates. No need to be refreshed. In case of dynamic RAM, it is composed of capacitors, need to be refreshed periodically. Example is main memory. And when talk about ROM, read-only memory, it is further categorized into PROM, EPROM, and EEPROM. PROM means programmable ROM, or only written once. EEPROM means erasable PROM, use ultraviolet light to erase data. And in case of EEPROM, electronically EEPROM can be erased using electronic impulses. Memory hierarchy. So you can see here, the main memory is available to CPU for operations, but how it can be made fast, because will also accessing to main memory also takes time. So in between, to reduce the access time, cache memory was introduced, and ultimately in CPU we have a register where data is stored. So this is the register in CPU. So uh, fast available data is the data which is available in register, and then data which is available in cache, and then data available in memory. So this is the fast, and then you can say this is directly available for CPU for operation, but compared to main memory, cache is fastest, and compared to this is fastest. Next, computer programming languages. We were talking about computer programming languages, so just categorized into different categories: computer programming language, non-computational language, machine language, assembly language, and high-level language. So computer programming language is an artificial language that can be used to control the behavior of a machine, particularly computer. It's like human language are defined through the use of syntactic and semantic rules to determine structure and meaning respectively. It is used to facilitate communication about the task of organizing and manipulating informations. Computer system programmers have been writing code. New technologies continue to emerge, develop, and mature at rapid pace. Now there are more than 2,500 documented programming languages. Now, non-computational languages. HTML comes under the category of non-computational languages. Often a programming language is embedded in non-computational language. When we talk about machine language can directly interact with the hardware, and which is understood by the computers, and it is written in the form of zeros and ones. And when we talk about assembly language, it is a low-level language for programming computers. It is written in the form of mnemonics. You can see this is an example for it, and this is how 5 is moved to the A1 register using this operation. Okay, and then 10 is moved to B1, and whatever is there in A1 B1, it is added. So that was the example of assembly language. Now high-level language. High-level languages are relatively easy to learn because instructions bear a close resemblance to everyday language, and because the programmer does not require a detailed knowledge. Now we will see about examples of HLL, that is high level language. BASIC was designed to be easily learned by first time programmers. COBOL is used to write programs solving business problems. Fortran is for scientific and mathematical problems. Then further window based systems came. Example is Visual Basic. Then further object-oriented programming language came, which is example is C++ and Java. This is the code written in C, that is in high-level language. Now we come to types of softwares. So computer software. Computer's hardware is useless without software. Software can be divided into two categories: system software and application software. System software helps the computer to carry out basic operating tasks. Application software helps the user to carry out variety of tasks. So this is the categorization you can see with this diagram here. Hardware is there, system software, upper layer, and then above is comes application software. So in the system software, operating system, language translators, and utility programs are there. operating systems for scheduling events, allocating computer resources. In case of language translators, interpreters and compilers come. And in case of utility programs, routine operations, managing data, like creating files, merging files comes. In case of application software, we can perform some operations using these languages. Now, as we have already seen this application software example is it is used to do the real work for users. An example is payroll, inventory control, manage student database. Other types of softwares are open source software, proprietary software. Open source software is computer software whose source code is available under the license that permits users to use, change, and improve software and to redistribute it in modified and unmodified form. In case of proprietary software, is software with restrictions. So you can see the difference. Open source is available to users to use, change, and improve software. In case of this, and this software comes with restrictions on using, copying, and modifying. An example is CAD, not an antivirus. Introduction to Internet and Web. All of you are aware, everyone is now using Internet. So Internet is largest network in the world that connects hundreds of thousands of individual networks all over the world. The popular term for the Internet is information highway. And rather than moving through geographical space, it moves your ideas and information through cyberspace, the space of electronic movement of ideas and information. And some interesting facts about internet is no one owns it. It has no formal management organization. Originally developed by Department of Defense. And to access internet, we use TCP/IP protocol. The users of internet are sending messages, sending or receiving files between computers, participate in discussion groups such as mailing lists, news groups, surfing the web. Now, what is web? Web consists of information organized into web pages containing text and graphic images. It contains hyperlinks or highlighted keywords or images that lead to related information. The collection of linked web pages that has a common theme or focus is called as website. The main page that of the pages on a particular website are organized around and linked back to it is called as home page. So how to access the internet? Through internet service provider or direct access to the internet using special high-speed communication lines and equipment. This we have seen it. Now, internet service provider, it's a commercial organization with permanent connection to the internet that sells temporary connections to subscribers. Okay. Now, for connecting to internet, we or surfing through web, we need web browser. It's a software which is known as web browser, which is used to connect you to remote computers, open or transfer files, display text and images. Example is Netscape Navigator, Internet Explorer. Nowadays you are using Chrome. So client and server structure of web. So web is a collection of files that resides on computer called web servers that are located all over the world and are connected to each other through internet. When you use your internet connection to become part of the web, your computer becomes web client and the software which you will be using is web browser. Okay. Hypertext markup language. The public files on the web servers are ordinary text files, much like files used by word processing software. To allow web browser software to read them, the text must be formatted according to a generally accepted standard. The standard used on the web is hypertext markup language. And generally those are written in the form of tags. This is for bold. So this is how it is written. Okay. Now, addresses on the web. So it is Each computer on the internet does have a unique identification number called as IP address. IP addressing system currently in use on the internet uses four-part number ranging from 0 to 255. And so four part you can see with they are separated with dots, and it looks like this. Okay. And domain name addressing. Most web browsers do not use IP address to locate websites and individual pages. They use domain name addressing. The domain name is a unique name associated with a specific IP address by a program that runs on the internet host computer. So the program which coordinates the IP addresses and domain names for all computers attached to it is called as domain name software. The host computer that runs this software is called as domain name server. Okay, so uniform resource locator, the IP address and the domain name each identify a particular computer on the internet. So they do not indicate where the web page HTML document resides on that computer. To identify web page exact location, web browser rely on uniform resource locator, which is four-part addressing scheme that tells the browser or transfer protocol to use, or domain name of the computer on which file resides, the path name of the folder, and the name of the file. This is an example of it: protocol, domain name, and path name, and then file name. HTTP. So transfer protocol is a set of rules that the computer uses to move files from one computer to another. Examples is Yahoo, Excite, all this you have seen a number of search tools, and how to find information. You are all aware now. You people are using search engines like Google. Now let us come to database. So database information is not useful if not organized. In database, data are organized in a way that people find meaningful and useful. So for that we use DBMS management system, that is database management system, to input, sort, organize, and store data. So basically, DBMS requires hardware, software, data, users, and procedures. Hardware means physical computer system, program that software that means program that allows users to access, maintain, and update the data. Data are actually stored in computer. So data are separate entity from software that access them. Users can be either end users, people who has access to the database, or application program, applications that access and process data, procedures, rules that are defined and followed by the users. Now, database architecture, it is divided into three layers: internal level, conceptual level, and external level. You can see here, this is an hardware. Directly internal level is interacting with the hardware, and conceptual level defines the logical view of the data, define the data model, contain the main function of the DBMS. Intermediary level free users from dealing with internal level, and external interact directly with users. You can see here user views displays data in familiar format. So next we will come to relation. Relation can be defined in terms of name, attributes, and tuples. So you can see here these are all fields which are we call as attributes, and one row is called as tuple. So there are a number of tuples here, and this table is known as relation. Okay, so the number of columns is called as degree of relation, and total number of rows is called as cardinality of relation. Next, operations on relation. We have number of operations. So operations we have categorized as unary operation, binary operation. In case of unary operation, examples are insert, update, delete, select, and project. So what is delete? Deleting a tuple. Update means changing the values of some attributes of a tuple. Select uses some criteria to select some tuples from the original relation. Project operation creates relation in which each tuple has few attributes. So binary operations, join, union operation, intersection operation, difference operation are examples of binary operations. The language which we use to interact with the database is SQL, which is declarative language where users declare what they want without having to write a step-by-step procedure. This is an example of insert operation, and we have other database models, example fragmented and replicated. Fragmented means data are localized, data are stored on local site, can be accessed from different sites as well as local site. Although each site has a complete control over its local data, that is global control through internet. Replicated distributed database, each site holds an exact replica of another site. Any modification in one site is repeated at every site. If the system fails in one site, the user at this site can access data at another site. So if we talk about levels of data, so database, one or more tables, table, which is a collection of records, record, a collection of related fields, field, one or more characters, and character at least 8 bits, 0, 1. Types of database programs, we have file management programs and database management systems. If we talk about advanced databases, we have data warehouses and data mining, client server database systems, and web database integrations. 5 characteristics of good database is data integrity, that is ensuring data is valid, data independence, data is separated from software, avoiding data redundancy, repetition of input data is avoided, data security, data is not accessible to unauthorized users, data maintenance. Why study information system? Now we will be talking about information system. So vital component of successful business, help businesses expand and compete. Business use IS and IT to improve efficiency and effectiveness of business processes for managerial decision making, work group collaboration. So that was the reason why we are using information system. And what is system? System is a set of interrelated components with clear defined boundaries working together to achieve a common set of objectives. So what is information system? An organized combination of people, hardware, software, communication network, data resources, and policies and procedures. Now, information system is all the components and resources necessary to deliver information and functions to the organization. IT is hardware, software, networking, and data management. In theory, IS could be paper-based, but we will focus on computer-based information system. So information system, for this, it's revolving near to it, different sectors are dependent. For example, management challenges, information technology, foundation concept, development process, business applications. So this is an example for it. Fundamental behavior, technical, business, and managerial concepts comes under the category of foundation concepts. Information technology, hardware, software, network, and data management, and internet-based technology. Major uses of IS in the organization, development, how to plan, develop and implement, management challenges, the challenges of effectively and ethically managing IT. Fundamental roles of information system in business, support of business processes and operations, support of decision making by employee and managers, support of strategies for competitive advantages. And you can see here how it works. Information systems, you have a down level, that is business processes and operations, middle level where which supports business decision making, and above that strategies and guidelines are made. So you can see here What is e-business? So e-business, use of internet technologies to work and empower business processes, commerce and enterprise collaboration, and online exchange of value. So